Okay, in the last video, we derived this logarithmic form as an expression for the inverse hyperbolic sine of x. And we closed out by noting that if this expression is true, if we take the hyperbolic sine of both sides of this equation, we would have that the hyperbolic sine of this function here will have to become equal to x. If indeed this is a true statement here. So we're going to go ahead and do this, take the hyperbolic sine of this function, and see if it does come out being equal to x. And let's see here. Saying that this is true, that would be tantamount to saying that e to the natural log of x plus the square root of x squared plus 1 subtract e to the natural log of x plus the square root of x squared plus 1 divided by 2 equals x, so we'll just say it would have to be equal to 2x. And we notice now this is a negative sign here, so we can rewrite the expression. This stays the same right here. Subtract. This could be the same thing as this to the negative 1 power. That's just a property of logarithms there. And that to the minus 1 would be 1 over this. So we can rewrite this as e to the natural log of 1 over x plus the square root of x squared plus 1. And this should come out to be equal to 2x. And remember now how natural logarithms work. If I say have this expression e to the natural log of y, that just equals y. So e to the natural log of this expression is just this expression. Same thing over here. So we have x plus the square root of x squared plus 1 minus 1 over x plus the square root of x squared plus 1 should be equal to 2x. But now, in the last video, we showed that this, let's just write this out, that 1 over x plus the square root of x squared plus 1, that equaled negative x plus the square root of x squared plus 1. So let's write this in place of this. And let's make some room here. And it looks like these will cancel. X minus negative x is x plus x. So indeed we get 2x equals 2x, and this side does come out to equal 2x. So yes, we put ourselves on firm ground then. Indeed, this is a true expression. And really, we don't have much more to say about the inverse hyperbolic sign. Let's say that, for example, though, we want to find the inverse hyperbolic sine of 1/2. Then that would be equal to the natural log of 1/2 plus the square root of 1/2 squared. That's 1/4 plus 1, which is 4/4. So this would be equal to the natural log of 1/2 plus the square root of 5/4. So we could probably rewrite this as the natural log of, that'd be over 2, the square root of 5 plus 1 divided by 2. And that would be equal then to the inverse hyperbolic sine of 1/2. So we don't have anything more to say about it. It's all pretty straightforward stuff. But come back and join us for some more videos, and we'll discuss more of the inverse hyperbolic functions and seeing how we can work with other ones besides the inverse hyperbolic sine function to get the log equivalence. So come back and join us for some more videos, and we'll try and work some more problems.